Hello, welcome back student to design and analysis of algorithm subject. So this subject is common for CSE as well as IT of the third year students. Let's see what we have completed in the last class. In the last class we completed 0 by 1 knapsack problem using branch and bound technique. Okay, what is branch and bound technique? Branch and bound technique is used to find the maximum problem or minimization problem. We are going to solve with this branch and bound technique. Okay, 0 by 1 knapsack problem we have completed with the using dynamic programming also. Okay, and we completed with the help of branch and bound. And today's objective is traveling salesman problem using branch and bound approach. So here, what is this traveling salesman problem using branch and bound technique? Already we have completed the traveling salesperson problem using the dynamic programming. In the dynamic programming, in the every stage it is going to take the decision and to visit the number of cities. Okay, here also the same problem, but we are using the branch and bound technique. What will happen in the traveling salesperson problem in the backtracking? While using the backtracking, if you do the traveling salesperson problem, we need to find all the possible solutions. From the possible solution we need to find the best one. Okay, so that was a procedure and it will take very long time. Okay, and the backtracking, if we talk about the backtracking is used the depth first search technique, DFS. Okay, backtracking use the DFS technique to solve the problem. It will go to the depth and it will solve. And when you come to the example of the DFS, like here 1 2 3 4 example. So first it will come here, then it will go here, like this. Okay, first it will go to the last, then it will go back reversing. So it will go level 1, level 2, level 3, level 4, like it will go in the depth. Okay, and it will take more time. But when you come to the BFS, breadth first search technique used by the branch and bound, and here it will follow like levels. Okay, like this is level 1 2 3 4. Here it is going in depth and here it is going level wise. So this take less time compared to the backtracking. Okay, so branch and bound technique, BB, branch and bound technique or branch and bound approach, we are going to see now. Okay, so here we have a problem. The problem is I have a map and the person can start from any one of the city. Okay, so I am starting point, I am taking this one. Example, if I take the city A, city B, city C, city D, so these 4 cities are there and the person should travel all the cities and reach to the starting point without repeating the same vertex 2 times. Okay, if it is visited to any one of the city, it should not visit again. So in that format, in that method, we need to select the graph. With this graph we need to solve the problem while using the branch and bound technique. Okay, branch and bound technique. So this graph, this map, okay, and this is called undirected graph, means it can go from city B to A or A to B. Okay, and it can be go to city B to city D or it can go to CTD to CTB. Any possibilities. This is undirected graph. So which one is a minimum cost that we need to. So here, so if we start from A to B anywhere, so I am starting from the A. Okay, let's take the example. Here the example, we converted that graph in that map into a graph. Okay, that graph we converted into the A to B. A to B is 4. A to B is 4. We are giving the weight 4. Okay, like this 4 cities. Okay, for this, if we take the example of this, then what will be the solution for this? Which city is a best solution? Which path is a best solution? If I go from A to D, it's 20. From 20 I can go to B. If I go to B, 25. If I go to C, is 35. So 35, 25, 20 is total 80. From here I need to reach 1 again, that is 15. Okay, so this is around 95. Okay, so for this the best solution is to go from A to from A to B, from A to B, and from B to D. Okay, from D to C, then from C to A. So what is the cost? 10 plus from B to D is 25 plus from D to C is 30 plus from C to A is 15. So what is the cost? Cost is 80. The best cost, okay, with the least cost we are completing and we are visiting all the cities and reaching to the home position. Okay, from the starting position only. So 10 plus 25 is 35. 35 plus 30 is 65. 65 plus 15 is 80. The total is 80 for this graph. Okay, the next one is, if we take another example, I am taking this example for solving the problem. Here also we have a 4 cities. Consider this is a 4 cities, A, B, C, D. Okay, and from A to B, what is the cost? From A, we are making a matrix. In this problem, branch and bound technique, we are going to use the matrices to solve the problem. From A to B, from A to B is 4. Okay, and from B to B to A is 5. Okay, so like this, whatever in the graph that we have completed in the matrices, like A to C is 12, then A to D is 7. Okay, so according to this graph we make a matrix. Now for solving the branch and bound technique, we need to follow some of the rules which is mentioned in the problem. So here, first thing, to reduce a matrix, perform the row reduction and column reduction of the matrix separately. So this is a matrix. To this matrix we need to find the reduction in row as well as in column. Okay, this is a 2 thing we need to do in the first step. The second step, a row or a column is said to be reduced if it contain at least one entry 0. Like here in this, any one of the row, when you are reductioning, so in the row it must be 0, any one of these 7, 12, 4 and infinity, so any one of this should be 0. And how we are getting this infinity? Because there is no root from B to C. From B to C there is no root directly, because of that it is infinity. We don't know what is a cost, so if it is not corrected directly, okay, then we need to make as a infinity. Okay, so the first one is we need to do the row reduction and column reduction. Then after that we need to do until we get at least one entry 0. Okay, so here for this matrix we will reduce the row reduction. Okay, we will do the row reduction. What is the first one? Infinity, 4, 12, 7, 5, infinity, infinity, 18, 11, infinity, infinity, 6, 10, 2, 3, 8. For this we need to do the reduction. Okay, row reduction. Row reduction means you need to check which one is a minimum in this given row. Which one? What is a minimum? Minimum is 4. And what is a minimum in this row? Minimum is 5. What is a minimum in this? We have a 6. Minimum in this, the last column, okay, minimum in the last column is 2. Okay, so we did this. So after removing this 4 from the minimum, so what will happen? This will become a 0. This will become a 0, because we have taken this 4 here. So the 4 minus 4 is 0. So which one is a minimum? Minimum is 5. And here which one is a minimum? 6. Which one is a minimum? 2. So write it here, 5, 6, 2. So this thing we modified from this. Okay, next one. This is row reduction. What is this? This is row reduction. In the same way, we need to make a column reduction. Okay, so for this matrix, okay, for this matrix we need to do the column reduction. Okay, column reduction. So in the column we need to check which one is a minimum. Oh, sorry, here we no need to write 5, 6, 2. Here we need to write 0, 0, because 5 minus 5 is 0, 6 minus 6 is 0, 2 minus 2 is 0. Okay, here we need to check column wise. From here column only 0, 0 is a minimum, because we are telling at least entry should be 0. So in this column we have 1 0, but here is 3 and here is 0. Okay, here is 3 and here is 0. So when we do this, so what will become here? Oh, sorry, when we are making 4 minus 4 is 0, so this all value will be changed. Okay, all values will get changed. let me do this. Okay, so here 0, 4 minus 4 is 0, this 12 minus 4 is 8, 7 minus 4 is 3, and the last one is 18 minus 5 is 13, 11 minus 6 5, okay, and 10 minus 2 is 8, and 3 minus 2 is 1, and this is infinity as it is. Okay, so whatever in the black color, that is row reduction. Okay, that is row reduction. Okay, after doing the row reduction, we need to do the column reduction. So what is in the column reduction? In the column reduction, from this we have a 0, so take 0 only. Here is 0, take 0. Here 1, and here 0. So when we do this, here 1 minus 1, 0, that you need to remove from there. Here 0, and here 8 minus 1 is 7. Okay, whatever the yellow color you are seeing, the numbers 7 and 0, that is column reduction. Okay, that is column reduction. So what is the total of the row reduction? 4 plus 5 is 9, 9 plus 6 is 15, 15 plus 2 is 17. 17 is a row reduction, and here in the column reduction what we have? Only 1. 17 plus 1 is equals to 18. So what is our reduction cost? The reduction cost is reduction cost is 18. Okay, what is our reduction cost is 18. Okay, now the next is we have completed the reduction, row reduction as well as the column reduction. Let's see here. Okay, here this first one, after reducing the row, okay, after reducing the row, we got this matrix. Okay, after this matrix we apply the matrix this, and we got the column reduction. Okay, row reduction and the column reduction. So what is the total cost we got it? We got the total cost is 18. Okay, we got the total cost is 18 from here. Okay, so this was the step 1. Okay, what is the step 1? We did the row reduction and column reduction. Now we need to do the step 2. Okay, we need to apply the step 2. After getting the reduction, we need to go from cost of, now we need to know the cost of A comma B plus reduction, whatever the reduction we got it, plus whatever the current reduction we are going to get. Okay, what are the current reduction we are going to get from the matrix. Okay, now if we go from A to B, if I go from A to B, so the condition is all A and B matrices should be in infinity. Okay, that all matrices should be in infinity. If you see here in the step 2, Okay, this was the answer, we got it, the matrix. Okay, after reduction, row and column reduction. Okay, after row and column reduction, we got the matrix. This, for this we are making infinity to A and B. Why we are doing? Because we are going from A to B. Okay, when we are going A to B, okay, A to B is infinity, the same way B to A will also be infinity. Okay, so you can see here the infinity, but rest of the infinities are the same where it was present like this. Okay, now we need to apply again the step 1 process to this matrix. Okay, we need to apply to this matrix, second matrix. So here from A, row reduction, now I am doing the row reduction. From A nothing is there, so we will say the 0. From B it is a 13, and from the C is 0 we have, so the minimum is 0, and here also is 0. Okay, this is a row reduction. And for the same thing, after row reduction we need to do the column reduction. Okay, column reduction. To which matrix we need to do the column reduction? After getting the answer, after minusing this 13 to this 13, we will get the 0. So for this matrix we need to do the column reduction. So what is in the column reduction? At least one 0 should be there, but here there is no 0. Which one is a minimum? Minimum is 5. Here is 0 only. Here we have 0, here we have 0. Okay, so in the column reduction, after doing the column reduction, this final answer we are going to get after column reduction. Okay, row reduction, then column reduction, then we will get the matrix, this one. This is a final matrix we got after reduction the row and column. Okay, so now we need to find the cost of the reduction for the given matrix. This is note 2. Okay, this note 2, cost reduction is, what is A comma B plus previous reduction plus current reduction. Okay, so here A comma B, what is A comma B? The value. So what is our A comma B? A comma B in this matrix, because we solve the problem while using the reduction matrix. So what is A comma B? A comma B is 0 here, plus what is R? Previously what the reduction cost you got it? We got it 18. Okay, we got it 18, plus what is the current reduction? Current reduction is here 13 plus row. What is the row reduction? The total cost is 13, and what is this? 5. 13 plus 5 is 18. So here also we need to write the 18. So what is the total cost here? We got it 36. If I go from A to B, then the total cost I need to travel is 36. Okay, if I take the example like third node, if I take the third node, okay, so here in the step 3 we are taking the same matrix, but what we are doing here, okay, here if I do one thing here. I will keep this, and for your understanding purpose, this was the matrix what we got it, and here we are checking A comma C. Here we are doing A comma C. When we are doing A comma C, A comma C, A comma C, whenever we are doing the same procedure, you need to apply here in the row reduction. Okay, in the row reduction, what is the thing? A row and third column we need to make as a infinity. Okay, the same thing. A row and C column, we need to make it as a infinity. Okay, and here when it is A to C, then it will be a possibility of C to A. C to A, this also you need to make as a infinity. So in this infinity, when we have this, now we need to check which one is a minimum, and here we need to do the row reduction. In the row reduction, the first one is 0, the second one is here also is 0, here we have a 0. Okay, and here also we have a 0, and here also we have a 0. Okay, we no need to do anything in the row reduction because everywhere is 0. At least we must have 1 0, so we have a 1 0. If we go to the column, okay, so in the column we need to do the column wise. Okay, in this column we have 0, in this column we have 0, in this column all infinity, no need of zeros, and here also is 0. So what is the total cost here? 0. Okay, so here we got the answer is 0. Okay, so here from A to C, A comma C plus R plus R power, current R. So here A to C, what is A to C? We need to go and check here. Here A to C we have the 7. Okay, what is A to C? We have the 7. So write it here 7 plus what is the R? We got the R in the first reduction is 18. And what is the current reduction now? 0 0. So we did not get anything. 0. So 7 plus 18. So what is the total cost here? Is 25. Okay, so here the total cost is 25. Okay, in the same way we need to do A comma D. Okay, so here I am taking the same matrix because this is a reduction matrix. After reduction we got this matrix. Okay, and here after this we need to do the here we need to do A comma D. Here we need to do the A comma D. So here when we have the A comma D, in the A comma D we need to make as a infinity. A row and D column. These two things we need to make it as infinity. Okay, and as A comma D, the same thing D comma A. So this one also we need to make as a infinity. Okay, now we need to do the row reduction. In the first 0, 0. Here the minus 5, okay, and here is 0. So the row reduction cost is 5 now. Okay, in the same way we need to do the column reduction. Here, after removing this 5 from the row reduction, we will get the answer this. For this matrix we need to do the column reduction. Okay, column reduction. So in this column we have a 0, no problem. Here also we have a 0, 0 minus. Here also we 0, and the last one is also 0. So what is the call reduction in the column is 0. Okay, so what is our final matrix we are going to get here? After this we have to check whether the cost we need to remove from the here. So after this we need to apply in the formula what is A comma D plus reduction matrix, whatever the reduction we did it, plus the current reduction. So what is A comma D? A comma D here, A comma D, the cost is 3 as per the matrix, plus what is the R? In the first matrix we got the 18 reduction, plus what is the current here? Only 5 plus 0 is 5. So what is this? The total cost of this is 26. Total cost of this is 26. Okay, so now, okay, now we got the reduction cost. Now we need to check, like this is a second and this is a third, okay, and this is a fourth city. So here we need to write what we got the answer from A to B, from A to C, from A to D. What is the total cost? You got it. From A to B you got it 36. We got it 36 from A to B. Okay, 36. From A to C you got it 25 is 25. And A to D you got it 26. From this you need to select the minimum matrix, which one is a minimum cost, and you need to go further. So which one is a minimum? Minimum is A comma C. So here we no need to take any other matrices, we need to take this matrix. Okay, you need to take this matrix to solve the next problem. Okay, so here we need to take this graph now for solving the next procedures. Okay, let's check it out. So here the possibility is, if I select the what is from where we gone, here we from A to C we have done. From C I can go to B or D. So now first I am going C to B. Okay, C to B. From C to B means C and B. These two things, C is a row, B is a column, we need to make it as a infinity. Okay, we need to make it as a infinity, and we are working on here, so we are not doing any other thing, just we are making the infinity, changing the numbers to infinity in C to B. So what is the row reduction here is 0, here 13 the row reduction, is 0 and here 8. Okay, when you do the row reduction here, so what is the total cost? 13 plus 8, the total cost is 21. Okay, so this is a row reduction. In the same way, we need to do the column reduction. Based on this answer, 13 minus 13 is 0, 8 minus 8 is 0. So this is a column reduction. So what is a column reduction? Everything will be 0. So what is the formula? From C to B plus, now we no need to take the R, because we need to see the cost of 3. Okay, cost of 3, because we have selected the third one. Okay, so what is the cost? Cost is 25 plus current matrix cost. What is the current matrix cost? Is 21. So what is this? R here. So what is the C comma B? C comma B, sorry, C comma B is a 0. Okay, plus cost of 3 is 25 plus current matrix is 21. Okay, so as per the matrix, what is the answer of our CB? C and B is a infinity. Okay, if infinity plus anything, the cost will be infinity. Okay, so here the answer is infinity. Next, here if we take the next one, okay, from C to D, from C to D, we take C to D, okay, row reduction with the same matrix. So what we need to do? C and D should be in the infinity. Okay, and here 0, 0, 0, 0, nothing is there to reduce in the column as row, as well as in the column we don't have anything to reduce. So what is the cost reduction for this? C comma D plus cost of 3 plus current matrix reduction. What is C comma D? C comma D as per this is 0 plus cost 3, means what the cost we got it? 25 plus what is the cost? Current matrix is 0. So what is here? 25. Okay, now we need to check what the answer we got it. From A to B, sorry, A to C, C to B, what is the answer we got it? We got it the infinity. And from A to C and from C to D, from C to D, what is the answer you got it? 25. So here we have a minimum is 25, so we are going to select the D matrix. Okay, this matrix we are going to select because we are selecting the 25 is a minimum. So 25, this matrix we selected and we did the row reduction. What is the row reduction? Now here we can go from D to B only. Only one possibility is and here the row reduction I am doing. After doing the D is fully infinity and B is full. Okay, and here we will get the 0 0 0 0, and in the column also we will get the same thing, 0 0 0. And what is the total cost we are going to get here? From D comma B plus cost which matrix? Okay, 6 matrix is whatever the matrix you are selecting, the cost of that plus current matrix. D to B, what is D to B? D to B in this we have a 0 plus what is the cost of 6? Is the cost of 6 is 25 plus what is the current matrix reduction after doing the row and column? Nothing, we got it 0. So what is the answer? 25. Okay, so what is our route now? The route is going from A to C, from C to D, from D to B. This is a route, and what is the total cost for it? The total cost for it is 25. Okay, the total cost for it is 25. So here if I go up, so here if we go with this problem from A to D, I will change the color. A to D, then D to C, then sorry, let me check what is the answer here. What we got? A to C, C to D, D to B. Okay, what is A to C? First it is went to the A to C, then A to C, C to D, D to B. Okay, let's go and check the graph. Let's go, we will travel like this, then we'll see is it a correct or wrong answer. First one, from A to C. Okay, A to C. What is the A to C? Is 12 plus from C to D. Okay, from C to D, from C to from C to D is 6 plus from D to B. What is D to B? D to B is 2 plus from B to C, B to A. What is B to A now? B to A is 5. Okay, so here 12 plus 6 is 18, 18 plus 2 is 20, 20 plus 5 is 25. We got the answer. Okay, so with the help of branch and bound technique we can solve the problem, and this is traveling salesperson problem. Okay, this the problem is traveling salesman problem using BB, branch and bound approach. Okay, check this and try to write in your book, then only you can understand this, otherwise it is a difficult for you for understanding. Okay, thank you very much. We'll see you in the next class. Okay, and here If you go to the matrix, so here summary is traveling salesman problem using branch and bound approach. Thank you very much. We'll see you in the next class.